Alright, we are at part 8. We are almost done. For this one, we are going to continue writing compound formulas from the given ions. So they didn't give us the charge this time, so we need to look them up ourselves. So magnesium is going to be +2. Bromine is over here in the -1. So in order to balance these out, we would have magnesium, and then to get the same total charge here, we would need 2 bromines in order to match that +2 that magnesium has. So potassium has a +1, sulfur -2, so this time we need to match the potassium to the sulfur, so we're going to have K2S. So now that would make an overall charge of +2 over here, -2 cancels out, and we're good. Chlorine. We have chlorine over here, -1. And aluminum, which is over here. Aluminum is a +3. I wrote those all backwards. Okay. So here, don't get tripped up. Some of these are tricky, so on this one I switched them. So you're not going to write Cl, Al. You're still going to do cation, then anion. So we have Al. So if this is a +3, we need to match that over here with chlorine. So chlorine, we need 3 of those atoms, 3 times -1, to match up over here, so we can have -3, +3, and get a net force of 0. So if we're looking at 60, sulfur is a -2. So this one, it gave us our transition metal charge. So in this case, if we have sulfur and a copper with a +1 charge, we need to match this +1 charge to the -2 charge. So we would have Cu, our anion first, 2 times +1 is +2, and then sulfur with the -2, that's going to cancel out. Now we've got sulfur -2 and copper +2. Those cancel out perfectly, so we don't need to do anything for this one. Cus. Here we have fluorine, and we have zinc. So we look at fluorine, -1. Zinc has a +2. So we're going to write our cation first, our positive first, so zinc. And then to match fluorine, we need 2 of them. 2 times -1 equals -2. -2, +2 equals 0. Alright, down here, cobalt and oxygen. We're going to do the same thing that we did with sulfur in 60, but now we're working with oxygen. So if we have oxygen is a -2, so the first one is pretty easy, -2, +2. We don't need to do anything with those. But when we get to CO +3, it's going to get a little tricky again. So this is where, right now, we have oxygen -2, cobalt +3. So we need to do that little switch with the charges where we're going to have oxygen. We're going to do 3 of them. So 3 times -2 would have a -6 charge over here. And then we're going to do 2 cobalt. 2 times +3 makes a +6. So those are going to cancel out. So I would write CO, cation first, 2 O3. Now that's a neutral compound. All right, this time I gave you the word. So aluminum, we know, is Al. Oxygen is O. Aluminum is +3. Oxygen is -2. So we need to do the same thing we just did up here, where we're going to have aluminum as our cation. Aluminum 2. Oxygen 3. Now I've got calcium, iodine, calcium +2, iodine -1. So to balance that out, we're going to need calcium and 2 iodine. 2 times 1, -1, is going to be -2. Then we have the +2, those will cancel out. So for 65, 66, 67, if we're looking here, magnesium is going to lose electrons, while sulfur is going to gain electrons. So if we find them on our periodic table, magnesium and sulfur, magnesium, the reason that it's going to lose electrons instead of gain is because it only needs to lose 2. It's a lot easier, takes a lot less energy for magnesium to lose 2 than try to gain 6. Whereas sulfur has 6 valence electrons, so it's going to be a lot easier for it to gain 2 instead of trying to lose all 6. Atoms are pretty lazy, so they always try to figure out which one they can do that's less work, and that's what they're going to do. Magnesium is never going to try to gain 6. It's always going to lose because that's just easier, less work on its part. For sulfur and oxygen, these have similar reactive qualities, and so we want to know why with our valence electrons. So if we find those two on the chart, sulfur and oxygen, they're in the same column. They have the same number of valence electrons. So your valence electrons determine the reactivity of the atom. This means oxygen only needs to spend the energy to gain 2 electrons. Sulfur only needs to spend the energy to gain 2 electrons. So they're both using the same amount of energy, the same amount of reactivity to try to gain electrons to fill up those outer shells. And the last one, explain why selenium is fairly reactive while krypton is not. So if we find selenium, Se, krypton. So they're saying selenium is going to be more reactive than krypton. This is because selenium has 6 valence electrons, so it will try to gain 2. It's going to do everything in its power to gain that so it can become a full octet where it's the happiest, so it wants to react. Whereas krypton is in group 18. This means that it has a full 8 already. Krypton, all of these ones in here, are pretty selfish. They have their 8. They are happy where they're at. They are going to do everything in their power to not lose or gain another electron. because that's going to set them off balance. So these ones, very selfish atoms, they're not going to react. They want to keep all of their 8 electrons, very greedy. Whereas selenium doesn't have all 8, so it wants to react to get those electrons that it needs to become an octet. Oh my.